In the name of Allah, the Compassionate and the Merciful. Hello guys, I am Salar Delawar Qashqai. In today's video, we're going to have an example about the finite element modeling of truss structure considering geometric and material nonlinearity effects. In previous video, we developed the large displacement analysis with this two-dimensional truss, 3 nodes, 6 degrees of freedoms, and also we applied the incremental displacement in degree of freedom 5, and based on 100 increments of displacement, the last step of this structure goes like this. So it is called the geometric nonlinearity effect. In this video, we are going to model both geometric and material nonlinearity. So we are going to define the stress and strain relations for this truss element by this formula. So if the strain is less than or equal to yield strain, so we have this formula, and if the strain is less than or equal to the ultimate strain, we use this formula. And we are going to model both in finite element method with my own coding as a Python code, and also I develop it with OpenSees code. And then you see all these two examples is the same result. So in these two examples, we are going to have an incremental displacement in degree of freedom 5, and in each step we are going to output the displacement and base reactions of this degree of freedom and also this degree of freedom. So let's see the OpenSees code and also Python code. All definitions is the same as previous video, but you see external loads, initial displacement, maximum displacement, and also coordinates of the each nodes of these truss structures, and also area of these elements as a sectional area, and also steel section properties, yield, strain, model of the elasticity, and also ultimate stress, and also yield, strain, and ultimate strain of these properties is going to be defined in here, and strain hardening modulus and with this formula, and also strain hardening ratio with this formula, and we define the convergence, iterations, and tolerance, and also truss length. This is the initial length of this truss length elements, and also initial displacement, and also defining the times for starting calculations, and also my Python code in finite elements method. So in each displacement increments in here, we're going to calculate the coordinates of the truss structures, and also defining the length of the elements, and also angles of each element, and also a strain of each element. And in here we're going to calculate the stress of each structure's elements based on define the strain. So you see guys, it is for element 1 and it is for element 2 as a second element, and then in here we're going to calculate the element stiffness with this formula as a stiffness of element number 1 and number 2. In here we're going to calculate the global stiffness, and in this example it's like the previous video, you're going to apply the incremental displacement, so we're going to change the matrix. So Kp multiplied incremental displacement as a FII, so the initial stiffness is going to be changed as this 2 array and 2 columns of this stiffness matrix going to be changed by 1 row and 1 column. And also we're going to define the external loads vectors, so by definition of the net force vector by minusing this value by this value, and then definitions of the this f vector and definitions of this while functions by Newton-Raphson method. We're going to converge the solutions. See guys, so we're going to calculate this as a f, and then defining the residuals, and if the iteration reaches to the ultimate, so the for this step the solution is not converged. But if the iteration is less than or equal to the maximum and we get the solutions, so the analysis is going to be continued to the next step, and then in here we're going to store the result from outputted data such as angles, residual stress, iterations, and also coordinates, strains of each element, and also length of each element. See guys, and also we're going to output the base reactions of this both 2 elements base reactions, and also outputting the displacement, and also we get the convergence conditions for getting the ultimate strain and also ultimate displacement checking, and also outputting the data for plotting. And let's see the OpenSees code. So I define the coordinates of this truss as same as these coordinates, so and defining the 2-dimensional modeling of this 2D truss, copying the nodes, and also defining the boundary conditions and also material properties as a bilinear kinematic hardening materials. So these relations is a bilinear material properties of this steel, and also defining the elements. I defined the core truss for this definitions of the geometric material nonlinearity effects, and also defining the external forces. And actually here we're going to run the external forces if we're going to apply these external forces. So both of them in this example is 0, and in here we're going to apply the incremental displacement in degree of freedom number 5 as a node 3, and we're going to output the base reactions and displacement. See guys, so by definition of this while, so we're going to calculate the each step, and you see guys, at the end in the post processing we're going to load the all outputted data such as displacement and each node's base reactions. We're going to plot it. So let's run it. So you see guys, after 13 seconds this code is going to be stopped for this Python code and also OpenSees code. You see guys, and then we're going to plot it with this base reactions and displacement relations. You see, all Python and OpenSees code has the same result. So my target in this video to show you how can we model very simple models of these truss structures with effect of material and geometric nonlinearity in finite elements method, both in my own coding of this finite elements method and also by using OpenSees programming very efficient library in Python. The codes are available in my GitHub. Please have a comment and tell me know about this kind of modeling. God bless you guys. Bye.